All right, so I've got here typed the equation of a parabola in a standard form. So y equals a constant times x minus h squared and then plus another constant. And I've got these sliders set up here so that the value of a, for instance, happens to be 1 right now. Now what I want you to notice is if the coefficient of the x squared term is positive, that the parabola opens upward. And so notice it's an upward opening parabola as long as that thing stays positive. And notice that the bigger that value gets, sort of the sharper, steeper the parabola is. So as I have this thing approach 10, you have a very sharply opening, steep parabola, and it flattens out as I approach 0. And of course, if we get to 0, then you just have the equation y equals k. So then it's just a flat line. And if I go negative, the parabola opens downward. Right, so the action of this coefficient of the x squared term, it kind of lets you know how broad the parabola is. A bigger value, bigger absolute value of a means a sharper parabola. So negative 10 here, very sharp downward opening parabola. Positive 10 will be a very sharp upward opening parabola, and then everything in between. So let's bring this guy back to being about 1. And then h, you notice, all it's going to do is change the x-coordinates. You notice where I have it, it's the vertex of the parabola is at x equals 1. Likewise, it's at y equals 1. That's because hk is just the vertex. So if I shift h, you notice so here it's at 3.2. Well, now the vertex of the parabola then is at positive 3.2. So shifting h just moves the parabola left and right. It just shifts where the vertex is horizontally. And likewise, shifting the k value is just going to move it vertically. So h shifts it, sets the x-coordinate of the vertex of the parabola. K sets the y-coordinate of the vertex of the parabola.
All right, kids, let's plot some parabolas. We're specifically going to plot these two parabolas. This relationship right here is kind of the standard, what's called standard form. So first thing we're going to do with the top one written in red is we're going to find the vertex of this thing. And so if you compare kind of to the standard form, you can see that the vertex, which is going to be located at hk, this is kind of this standard notation. So you can see that h here is going to be negative 5. And the k value is going to be 3. So negative 5 and then up 3. So let's go ahead and put the vertex in. So we got to go 5 units over on the x-axis and 3 units up on the y. So the vertex of that parabola is going to be right there. Then the next thing we want to look at is kind of this parameter p here. One thing you're going to notice, or one pattern you're going to find, is that when this coefficient of the sort of the x squared term is positive, that's going to be an upward opening parabola. So it's gonna face that way as opposed to like pointing down like this. So this parabola that we're finding is going to be upward opening, and what we can do is so it's gonna open up. And what we can do is we can find this parameter p. So 1 over 2 needs to be equal to, well, 1 over 4 times p. So as it turns out, this p value is going to be 1/2, right? Because 4 times 1/2 would be 2, and then you'd get a 1 over 2 there. So p is going to be 1/2. So to help guide us, one easy thing we can check is, for instance, when x equals 0. So that would be like finding where this thing would cross the y-axis. When x equals 0, you'd have 5 squared, which is 25, over 2, which is 12.5, plus 3 is 15.5. Well, so this is 10. So way up here at 15.5, way off the paper would be where this parabola would go. So that'll give us kind of the rough shape. So this thing's really going to take off like this. Go sailing up there. And what this 1/2 is that tells us how far up the focus is from the vertex. So if you go up 1/2 a unit, that's going to be where the focus of that parabola is. So this thing's going to go tearing off to eventually to a coordinate of like over 0 and up. What did we say? 15.5. So there's that first parabola. Let's work on the second one here at the bottom. This is going to be a downward pointing parabola since it has this negative coefficient of the x squared term. Let's go ahead and find h and k. And so you can see from kind of comparing to the standard form here, you'd have hk equals, well, it looks like the h here is going to be -4. And our k value here is going to be -5. So what we're going to need to do is go 4 units over and then go 5 down. 1, 2, 3, 4, 5. So the vertex of this parabola is going to be down here, and it is going to be downward pointing. Likewise, we can find this p-value. So 1 over 4 times mystery number needs to be equal to -2. And so it looks like we want this 4p, this bottom number here, to be -1/2. So 4 times a mystery number will get you to -1/2. So we basically have to divide the 4 by 8. Okay, so it looks like the p is going to be what, -1/8. So our p value here is going to be -1/8. And then that's going to give us, so you can check that, 4 times -1/8, you'd get a -1/2 downstairs, which would give you a -2, so that's correct. So that means the focal point of that parabola is only going to be 1/8 of a unit down here from the vertex. And it's downward pointing parabola. To see where it crosses, you could play this game again where it crosses the y-axis. You could play this game again where you plug x = 0. So that would be 16, because you plug in x = 0. 4 times 4 is 16. And then times -2 would be -32. And then -5 would be -37. So it's really going to be way down there. So that's going to be a very steep parabola. It's really going to be bending like this. And so what that's going to do is head down to eventually cross the axis down here. It'll eventually go to over 0 and down. What did we say? Let's see, -37. So it's eventually going to go down there. So this parabola is skinnier because the absolute value of this coefficient is larger. So that makes the parabola skinnier. And it's negative, so it opens downward. So that would be how to plot that parabola.